Geometry, Module 3. Topic 1, Lesson 1, Lesson 2, page 467. We're wrapping up Activity 3. Activity 3 has been a conversation around side angle side similarity. We have 3 of them that are useful. In fact, the list is side, 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 angle, angle, and side angle side. Let's talk about the last part right here, wrapping up this page. Have a highlighter and have something to write with. Of course, you should also have already done page 466. So if you haven't watched that video and haven't answered the questions on that video, including the ones where you're supposed to go back and measure DE, D prime, E prime, etc., go do that. Describe how you can use transformations to determine whether 2 triangles are similar. When 2 pairs of corresponding sides are proportional, that's the word we're looking for, and the included angles are congruent. That's also true. Transformations are rigid motions like translations, reflections, rotations. Similarity is not a rigid motion. Dilations, which stretch or shrink, dilations are what we need to finalize the transformation required to show shapes are the same. So let's make a list. I can use combinations of translations or reflections. What was the third? It was rotations, and I want and or. To position the triangles so that a dilation can stretch or shrink one triangle onto the other. So first of all, we want to kind of like get the triangles or the shapes lined up, and then we want to use a dilation. And dilation is going to have some element of a scale factor, and that scale factor is going to shrink the object down so that it lines up, or it's going to expand the object so that the object is lined up on top of the other one. Then we'll notice that the angles are exactly congruent, because when you dilate, you can, in X and Y directions, you can keep the angles the same. Because you demonstrated that the SAS relationship is true, you can now refer to it as a theorem. The side angle side similarity theorem, SAS similarity. If the 2 corresponding sides of 2 triangles are proportional, there's our phrase, and the included angles are congruent, there's our phrase. By the way, congruent is the symbol equal with a tilde on top, then the triangles are similar. So our symbol for similar is a tilde, a squiggle. You literally have to provide 2 fractions that are equal to each other, and you literally have to provide the angles between. So I'm going to do that. I'm going to use a squiggle instead of a spike. I'm going to say squiggle AB and squiggle ED. Squiggle for similar, tilde for similar. Double squiggle, double squiggle, double squiggle, double squiggle. And then last of all, this is where they have to be exactly congruent. Angle A and angle D are exactly congruent. If you can show all of that, you have the triangles are similar. Thank you for watching this video. I'll show you what the next page has in store. It's page 468. It's the last page of this lesson, so thank you for watching, commenting, liking, and subscribing. Stick around for page 468, and we'll finish out lesson 2, triangle similarity congruence theorems. Similarity theorems. Okay, bye.